I have another technique for the convergence of the sequences. Let me show you by an example before giving the theorem for this part. Let's say I have such a sequences, right? 2n squared plus 5 over 3n. So the question is this. If I didn't have the square root here, right, the result would be easy. I would either use the L'Hopital rules or algebraic technique with the main limit theorem, and then you can get the limit as infinite. This is a divergent sequence, right? But this time, since I have to write the square root here, I don't know what to do. I cannot write it. I can take the limit directly. That is why, okay, I need a new tool, okay, so that it can help me out to solve this type of problem. That's what we call the continuous function theorem for sequences. Let's see, okay, what is it about? Let's say I have a sequence real numbers, as you know. If I know the limit of this sequence, and if I have a function, guys, if I have a function which is equal, also continuous, and defined at all an, then the limit of this function, for an is going to be equal f of l. You see that? What it says, if I know, right, what the limit of an goes L, and then I do the same thing, I repeat the same thing right under the function, under this function. This time, right, the function limit, right, at those points will converge to the f of L. So basically, what I do here, I switch the limit by the function. Okay, that theorem will allow us, okay, I can switch the limit by a function. Let's see, okay, in an example. I'm going to show you, okay, how to use this theorem to solve some problems. Look at this example. Let's see one of the square root, okay, examples. I have 27n plus 5 over 3n plus 7. So that's my sequence limit problem. As you see, since I have the square root here, I cannot take the limit directly. What I should do first, as in the theorem, I'm going to switch the limit by a function. What I will do, look at that, I can switch the limit. I can put it inside 27 plus 5, 3n plus 7. How I do that? Since if my function is equal, f of x is equal, look at the square root x, right? And then my sequence is, which is equal 27n plus 5, right? Over 3n plus 7. Do I know where it goes? Yes, I know that, right? I can look at the coefficients, or I can use the L'Hopital rules, or I can use the main limit theorem with some algebraic technique, and then I can see that this limit will go where 9. Okay, what the theorem says, if you know, right, that the limit of the an, it goes 9, and then the limit of function for this sequence will be equal, right, f of l. That's great, right? So it is going to be equal, which is 9, and it is going to be equal 3. I left the limit of this an to you so that you can easily solve. Either you can, as I mentioned, right, you can use the L'Hopital or the algebraic technique we learned at the beginning of the sequence topic. Another example. It's going to be a little bit different example. Limit goes infinite. ln n plus 2 minus ln 3n plus 2. This is my question. But look at it. Let me try to take the limit, right? The limit of ln function, right, when n goes infinite, is going to be infinite. And then another ln function I have here, and then that's going to be infinite as well. But do I know what the result of infinite minus infinite? No, right? This is undetermined. Undetermined. And it is not gonna be 0, guys, okay? It is not 0. Please don't do that. Don't say it is 0. What am I gonna do then? First of all, I have a couple features of ln function I can use. So I know that I can write this, okay, in this way. n plus 2 over 3n plus 2. Great. The next step is to try the limit again. But when I look at, right, this sequences, I don't know how to do that. I cannot take the limit of ln function since I have, right, another term here which I cannot take the limit directly. That's why, okay, I will be using my theorem about the continuous function, since ln is a continuous function. That theorem says I can switch the limit by this function. Instead of taking the limit of the left hand side, now I can take the limit of this part. And then I know what is the limit of the right inside. The limit of this is going to be equal, if you take the look at, if you apply the L'Hopital rule, since it goes infinite over infinite, if you apply the L'Hopital, the derivative of the top part is going to be 1, the derivative of the bottom part is going to be 3, so the limit is going to be 1 over 3. So my result is going to be ln 1 over 3rd. You can simplify more doing this one. ln 1 minus ln 3. Since ln 1 is 0, my result is going to be ln 3. Okay, let's stop here. I have some more topic for the sequences in the next section.